All right. Our question says, upon analysis, a compound was found to contain 31.3% of calcium, 18.74% of carbon, and 49.96% of oxygen. The empirical formula is, that's what they want us to find. So here's a tip. Notice again that these percentages add up to 100%. So let's treat it like we have 100 grams of the compound. Alrighty, so of course, if we are going to treat this like grams, we would have 31.3 grams of calcium, 18.74 grams of carbon, and 49.96 grams of oxygen. All right, so let's see how many moles we have of each of these. Looking at our calcium, which has an atomic mass of 40.1, and we have 31.3 grams of it, using this converter to convert from grams to moles, 1 mole of carbon is 40.1 grams. So in essence, you're going to divide 31.3 by 40.1, which of course is going to be just under 1 mole, 0.781. For our carbon, which has an atomic mass of 12, we would divide our 18.74 by 12, giving us 1.56 moles. And for our oxygen, where we have 49.96 grams, we would be dividing that by the atomic mass of oxygen, which is 16. So every 16 grams is 1 mole for oxygen. So if we divide 49.96 by 16, we get about 3.12 moles. Okay, so in our second step, we want to compare the ratio of each of these amounts by the smallest answer that we got here. So for the calcium, of course, 0.781 divided by 0.781 gives us 1. For our carbon, if we divide our 1.56 by 0.781, we get 2. And for our oxygen, where we have 3.12 moles, we divide that by our smallest number of moles, 0.781, we get 4. So we can use these ratios to figure out our empirical formula. We would have 1 calcium, 2 carbons, and 4 oxygen. And we would call this a calcium oxalate. And calcium oxalate is what makes kidney stones, which you can get sometimes if you don't drink enough water. So drink up your water.